Have you ever played with swings in the playground? The back and forth motion of the swing can be both relaxing and exciting. When I was young, I wished that I could swing infinitely and never stop. Well, the question is, can I? Of course, I might be called back home to having to eat dinner, but if I didn't have to go back home, and I just sat on the swing back and forth, would it be possible for me to swing perpetually? And are there any perpetual machines? Well, let me explain why I can swing first. In physics, you've probably heard of potential energy and kinetic energy. Now, potential energy has to do things with gravity, mgh, while kinetic energy is 1/2 mv squared. Now, with that, we've also learned about conservation of energy. Now, the law of conservation of energy states that energy can neither be created nor destroyed. It can only be transformed or converted from one form to another. For example, how kinetic energy can turn into thermal energy. Now, swings work by converting potential energy into kinetic energy. When the swing is at the very top, it has potential energy, but when it reaches perpendicular to the ground, it has kinetic energy. And it sort of just converts back and forth as you swing on the swing. Now, as we know, kinetic energy has more to do with how fast something is moving, as it has to deal with velocity, while potential energy is a type of stored energy. Now, because of those two energies, that's basically what makes swing on a swing really fun. However, unfortunately, a swing is not a perpetual motion machine. As a perpetual motion machine is a machine that can continuously move back and forth infinitely without an external energy. Due to the first law of thermodynamics, it states that the energy can neither be created nor destroyed, only altered in form. That means the swing cannot be a perpetual motion machine, as a swing is not a perpetual motion machine, as maybe you've tried. It doesn't swing infinitely. Now, you might ask, if you gave a swing initial energy, could the swing continually move? According to the second law of thermodynamics, with each energy conversion from one form to another, some of the energy becomes unavailable for further use. That means that when someone swings, every time the potential energy converts to kinetic energy, the efficiency of the conversion cannot always be 100%. Now, this is given by a formula that can be used to calculate efficiency. We also see efficiency problems happening with motors, certain motors not working to its full potential. And yeah, so some of the potential energy spreads out during the conversion and becomes another form of energy. So for example, let's say the energy efficiency is 80% every time it converts. Then when the potential energy converts to kinetic energy, we can only get 80% of the energy we were supposed to get. And once again, if we go through that same process, we would only get 64% of the energy, which means that the swing would gradually come to a stop. Now, the second law of thermodynamics also tells us that even though the quantity of the energy doesn't change, the quality of the energy changes, which means that if the efficiency of the system is affected, perpetual motion isn't actually possible, because due to it not converting 100%, it means that the swing won't reach its original height in which it was perhaps released from. Because as we know, potential energy to kinetic energy, some of efficiency is lost, and then back to potential energy with mgh, the height isn't reached. in converting back to kinetic energy with the first efficiency not 100%, the swing also starts to slowly slow down, which might be familiar to some people who always chooses to go on swings. So there isn't really a perpetual motion machine that really exists in the world as we know of, due to it not being 100% efficient with every conversion, but also due to external forces affecting it, such as air resistance and things that go against the motion of the swings. Well, isn't Earth a perpetual machine? Now, an Earth itself rotates continuously all the time, and as a matter of fact, the Earth is not the type of one perpetual machine. Now, because the Big Bang gave the Earth initial energy, the Earth is not the type 2 perpetual motion machine. Because scientists have discovered that speed of the Earth's center rotation becomes slower and slower. So that's also not a perpetual machine. So someday the Earth might stop rotating too. So what would happen if the Earth stopped self-rotating? Well, would the rivers still flow? What would happen to us? What about day and night? I'll leave those questions to you. Thanks for watching.